All right, anyone that's been following the mud fossils, the work I've been doing in mud fossils, has seen that the veins and the arteries show up in rocks because rocks literally were from living creatures that became petrified in wet mud, normally, in wet environments, let's put it that way. And then a lot of them in mud, and some of them in actually in pools of blood. Some of them were in sandy soils and so forth. So they've been preserved in a number of different ways. Some of them in low pH, high pH, and that has a huge effect. Now, this is an artery, and the reason I know it's an artery is because first of all you see this redness near it, which is from the FeO2 blood, which is the oxygenated blood. Secondly, you can see the layers of the tubing which makes up your blood vessels, and they are literally made out of different materials that isolate everything else from the blood. Obviously, nothing here can penetrate to get down to your blood. That is the nature of all of the different, it's called fascia and connective tissues, and they surround organs, and they surround blood vessels, and they surround everything in the body, and there's like 25 different kerogens and 25 different collagens, and there's all kinds of material that the body has to work with. It can keep acids from coming in. It can keep alkaline stuff from coming in. You know, the acids in the stomach and bile and yada yada yada, all that stuff. Now, so what do you end up with? An interior that is isolated from the exterior. And normally the blood flows through here. Well, in an artery, there is no restrictions to the blood flow. There's no valves, there's no anything. When it pumps, it pumps. And when it pumps down, it leaks into the sides here and there to feed the tissues that surround the arteries and the arterioles, or arterioles they call them, the little tiny blood vessels that inject oxygenated blood, which is the red blood, into tissues, and then it gets sucked back up as it turns blue, and when it touches oxygen again, it turns black in the mud fossils, because that's FeO2 iron oxide, which is black. This is FeO3 iron oxides, which are red. And there's more of these. I'm going to move this, and it'll be a little shaky. You see, this is leaking out of that. That's what you see. That's the blood. That's the red. When you see red, it's iron, primarily. Anyway, now there's the artery. Now, if we go this way, we come right over to the vein. I've shown this a million times. Well, maybe a half a million. And this is what happens. Oh, focus in. Hold on. Let me lock this down. See if I can lock it down and focus in. Now, that is leaking directly out of the vein. And they don't leak out of veins. They sort of congeal on the veins because there's clamps inside of veins. And the reason there's clamps and the valves, or whatever, however you want to call them, they stop the blood from returning backwards in the body to contaminate the good tissues. Now, so what you end up with here is this black vein. And that's where the blood was coming out. I mean, it's not hard to understand what's going on here. Here's the artery, and it happens all the time. Exactly the same way, the artery, and there's a vein. Now, I'm going to show you the anatomical on this, and you'll see exactly what I'm saying. By the way, what you were just looking at is this. It's a geode. Geodes are bone balls that have veins and arteries, and the bone, the casing of the bone, which is just like where this here is the bone casing that's inside. It's the hard bone, and then interior to that is the soft, spongy bone, it's called. And that boils out inside of geothermal areas, and you end up with this kind of stuff, which is the boiled out contents. And then as the continued boiling occurs, whatever the solvents are in that thermal activity starts to create crystals, just like it does in rock candy when the kids make rock candy with strings, inside these holes that have been boiled out, just like you boil out bones. And and this could be done. I've made fossils myself, I made the feldspar, which is the I have a video on it, but anyway, the silicon gets invaded with oxygen in certain wet conditions, and you end up with SiO2, which is silicon dioxide, which is sand. And this is a whole. All this is very obvious. It's just it needs to be looked at with a serious consideration, because it's just not being taken serious. All right, this is about geodes, and it says they're spherical rocks with hollow cavities lined with crystals, and that's exactly what happens. The bone head boils out, and the contents is called spongy bone and minerals and blood and so forth and marrow. That boils out in these thermals, and you end up with metal seeds, because blood contains all kinds of different metals. And the metals don't boil away like the volatile organics, so you end up with these little crystal seeds in here. And as the percolates, because it's still flushed with hot waters and so forth, it creates crystals just like it does in the rock candy. And geologists have no clue about this. They've long been challenged to explain how geodes and mysterious spherical rocks form. Well, they're bones. That's why they don't understand this. Geodes are variable phenomena, blah, blah, blah. Now, what geodes are the round ones with the holes in them. Then they have another one, which, these contain the cavities with the crystals. But then there's other ones that were completely filled with small compact crystal formations, such as agate, jasper, so forth. Now, some of these could be well, they never were boiled out, let me put it that way. And also, agate normally, to me, indicates that it was not animal, it was plant. Just like the trees, the petrified forest trees, turn into agates. Now, and it goes on and on. Now, I'm doing this under the Fair Use Act, and I'm just commenting on it. There's no profit I'm going to make on this. I just want it known this is what's real, and how they created and so forth geodes. Now, what really has to be done is looked at this in the way that I'm looking at it, because it can't be looked at in any other way. Those chemicals just don't show up there, and those structures do not show up for no reason at all. There's always a reason. It's a universal principle of causality. Everything that happens is caused by something, and I showing you what the cause is. So I'd like to have this thing looked at, and I'll show you the anatomy of what blood vessels look like, and you can see it's very obvious. And I have many videos about the transfer of blood and how it moves through the blood vessels and how it turns black, and I have them actually can see from one side going to the other, where it comes in red and it ends up turning lighter color and then brown and then all the way to black, and all the little tiny blood vessels just get sucked back up into the veins, up into the heart. It's fully understood. It just needs to be looked at with a realistic eye. All right, this just shows you that coming from the aorta, these is a big tubing. It breaks down into arteries, which are a little bit smaller. Then it goes into the arterioles, and then into the capillaries, or the web through your tissues. And as it's done, all of the oxygen is being consumed inside your body. And then when it gets to the other side, it's purple, blue inside your body in vein blood, and it shows through the video, and it is sucked up exactly the same way it was injected. It gets sucked back up, and it gets the vena cava up to the heart and the lungs to be reoxygenated. Now, when it enters this, there's valves in here. They're not showing you this on here, but there's actual valves in here that will not let the blood go backwards to recontaminate that blood. And I'll show you some other stuff. All right, once again, here's the deal from arteries, and we saw the artery that I showed you in that geode. It has all that same articulation. There's no difference. And once you're dead and you're in the wet environment of where it's wet, these things are designed to work in that environment, so they don't really even know hardly you're dead. So the blood will congeal that's inside the veins, and the blood that's in the arteries blows out because there's no valves. All right, this is one of the groups I have about mud fossils, and it's been on for a year or so. So come in, join the group. Mud Fossils, a New Science, and you can go in your backyard and find these fossils right in your backyard. Every rock that you're going to find is a discrete rock. It's a chunk of rock by itself, not part of a lava formation. Will display some evidence that there was vascularization in there somewhere. Now, it's a little tricky to find it, and a lot of them you may not be able to find it at all, but a lot of them you will. So all you have to do is look, and within 15 minutes, I guarantee you're going to find something that you'll be able to discern that there's a vein and an artery if you follow my videos. And I would like to have somebody come forward and try to get this validated one way or the other. Maybe I'm crazy, but I don't think so. I think the evidence is unimpeachable, but it has to be viewed, and it isn't allowed. So nobody will correspond with me. Nobody will, in academia, will put themselves on the line, and that's literally what it is, because they will be condemned. But this is very, very poor looking for academia, extremely poor, that they can't come and challenge what is obviously a complete, total challenge to what they're teaching. And I'm challenging with evidence, and they're challenging with ignoring, and that's not correct. So someone should do something about this. All right, here's an example of crystallization, obviously. Now, this is a coyote skull, and I suspect this is not all that old. And it's obviously been in a geothermal area where it boiled off all the meat and so forth. And what's left is there's some metal seeds apparently were left in areas here, and they begin to crystallize in that geothermal particulate, and because it's blue and it's an amethyst type, I think it might be, I can't remember, there's a couple different minerals that do that. I think it might be vanadium or manganese, I can't remember, magnesium, who knows. But I mean, it's easily understood, and they can easily be tested. They're just not being looked at. Here's something that shows, this is from a clamshell. You can see it's a clamshell, and it's grown crystals, and more than likely there was some kind of organic material down there that contained some metals, and then they started to grow off of those seeds. All right, once again, Fair-Usac. This is a crystal cave. They're down in Mexico, and that is from a giant creature's bone. This is the bone part on the outside, and these are the crystals that are growing from the bones. Now, these giants that I have shown, and there's nobody's challenged this, and nobody can challenge it. They are literally miles high, and the bones cavities are enormous. And this is what happened here. And there's other places I'm seeing from. There's a site on there called something about ancient archaeology or something like that, and unbelievable. What they're finding, all of these huge organs and so forth, from hearts and tendon straps, and they're all crystallized in amethyst, and gigantic things, and they're finding these, and I'm sure these were in geothermal areas. Now they've maybe stopped being geothermal now, obviously. They got people sitting around on them, so there's no more geothermal activity there. But at one time, that was geothermal, and it boiled the contents, the soft, spongy contents of bones and organs and things, and what was left is the scaffolding and the holes. That's where these caves come from, and then the caves begin to create the crystals just like this.